So you log into the AWS console, right? You spin up your infrastructure, and it just feels, it feels completely frictionless.
Oh, yeah. Maybe a bit too frictionless, honestly.
Right. You deploy resources across the globe in like seconds, and you never even touch a piece of physical hardware. But then, month end hits.
And the invoice arrives.
Exactly. The invoice arrives, and you suddenly realize that frictionless provisioning means frictionless spending. Like the cloud goes from being this enabler of infinite potential to just a massive financial liability.
Yeah, because when there's no physical limit to what your engineering team can build, there's absolutely no physical limit to what they can spend.
Which is terrifying.
It really is. And, cost optimization isn't just some accounting issue that you toss over the wall to finance at the end of the quarter. It is a fundamental core architectural requirement.
Right. Which brings us to our mission for this deep dive. We're digging into a stack of AWS SAA CO3 exam notes today, specifically zeroing in on this concept of the frugal architect.
I love that term, the frugal architect. It's all about ruthlessly aligning your infrastructure choices with measurable business value.
Exactly. And our goal today is to help you, the listener, navigate all these friction points of AWS pricing. We want to help you dodge the financial traps they set on the architect exam and, practically figure out how to keep your startup's burn rate under control in the real world.
Because if you don't know the rules of the game, it's just a bottomless money pit.
Yep. So let's start with the foundation, which is compute power. Every cloud journey starts with compute. And I've been looking at the 4 primary pricing models for EC2. So we've got on-demand, reserved instances, savings plans, and spot instances.
Right, the core 4.
Yeah. And honestly, the architecture decisions here, they feel a lot like real estate negotiations to me.
Oh, that's a good way to look at it. How so?
Well, okay, so on-demand is like booking a high-rate hotel room. You can leave whenever you want. There are no strings attached, but you pay a massive premium for that flexibility.
Right.
And then reserved instances and savings plans, those are like signing a long-term commercial lease.
Yeah.
Like you commit to the space, and the landlord slashes your monthly rate.
That commercial lease analogy holds up beautifully, especially when you look at the actual supply chain mechanics of a cloud provider. AWS has to purchase physical hardware, right?
Yeah, they're buying actual servers.
Exactly. They construct data centers, they secure power contracts years in advance, they crave predictability above all else. So when you run an on-demand instance, AWS is carrying all of the forecasting risk.
If they don't know when you're going to shut it down.
Right. They have to guess your capacity needs and maintain this massive buffer so your server spins up instantly when you click the button. And they charge you top dollar to carry that risk. But when you commit to a 1-year or a 3-year term,
You completely remove their forecasting uncertainty.
exactly. You give them a guaranteed revenue stream, and in exchange, they reward you with up to a 72% discount.
Wow, 72%. But, the friction between choosing a reserved instance versus a savings plan, that always feels a bit murky to me. They both require that 1 or 3-year lock-in, right?
They do, yeah. But the difference is in the rigidity. A reserved instance, or RI, is heavily tied to specific technical attributes. You are locking in a specific instance family, a specific operating system, and often a specific availability zone.
So you're telling AWS, I will use this exact type of hardware configuration right here for 3 straight years.
Exactly. It's very rigid. If your application architecture evolves, say you need to switch from compute-optimized C5 instances to memory-optimized R5 instances, your reserved instance discount does not travel with you.
Wait, really? You just lose the discount?
Well, unless you jump through the hoops of using convertible IRIs, which, they offer a lower discount anyway.
Okay, so that's where savings plans come in, right? Because they shift the commitment away from the technical resource to a purely monetary baseline.
Yes. You just commit to spending, say, $10 an hour on compute power.
So it separates the financial commitment from the architectural implementation.
Exactly. A compute savings plan gives you the freedom to change instance families, swap operating systems, or, even migrate workloads between entirely different geographic regions without losing your discount.
Oh, that's huge. So you get the commercial lease pricing, but you maintain the freedom to rearrange the office furniture however you want.
That's a perfect way to put it.
Okay, so that leaves spot instances.
Yeah.
Now, spot is to me, it's like flying standby on a severely overbooked airline.
Yeah, that's pretty accurate.
That's incredibly cheap, right? Up to 90% off the on-demand rate.
Yeah.
But if a full-paying customer suddenly shows up at the gate, you just get bumped.
Yeah.
But, How does AWS even justify slashing the price that deeply?
Well, remember that buffer we talked about? AWS has to maintain a vast pool of extra servers to absorb sudden, unpredictable spikes in on-demand traffic from massive enterprise customers.
Right.
But an idle server sitting in a rack is still burning electricity and generating zero revenue. So, selling that buffer capacity as spot instances allows AWS to monetize unused silicon.
Ah, okay. But the catch is the interruption mechanism.
Right, the termination notice. The moment AWS needs that capacity back for an on-demand request, they send your instance a warning, and 2 minutes later, your server is just gone.
Poof. Gone. Which means you obviously can't run a user-facing API or like a transactional database on a server that might vanish in 120 seconds.
No, absolutely not. Your users would just get hit with 502 bad gateway errors all day.
Right. So Spot has to be strictly for fault-tolerant, flexible workloads, like batch processing, log analysis, maybe video rendering jobs.
Yeah, anything where the application can pause, save its state, and just seamlessly resume on a new instance when the price drops again.
Okay, that makes sense.
And this leads directly into one of the most common traps on the SAACO3 exam. You will definitely encounter what I call the predictable 3-year workload scenario.
Oh, the exam trap. Okay, break this down for me.
So the question will outline an application that is going to run continuously for the next 3 years, and then it simply asks you to identify the cheapest compute option.
Okay, and the word cheapest just acts like a blinder for people taking the test.
Exactly. Test takers immediately look for spot instances because, well, a 90% discount is mathematically the lowest rate available.
Right, they fixate on the discount and completely ignore the architectural constraint.
Yes. A continuous workload cannot survive the constant interruptions of the spot market, so spot is instantly eliminated.
And on-demand is also out, right? Because paying premium hotel rates for a continuous multi-year deployment would just destroy your budget.
Precisely. The exam is testing your ability to balance workload stability with financial commitment. You have to pivot to a reserved instance or a savings plan for that scenario.
Okay, that's a massive tip for anyone taking the exam. Now let's pivot a bit. Getting your compute lease right is really only half the battle, because those EC2 instances, they are constantly processing and generating data.
Which means we have to address where all that data ends up.
Exactly. And moving into S3 presents a totally different pricing dynamic. Like, with compute, you're paying for time. But with storage, you pay for accumulation.
Yeah, and S3 seems infinitely cheap at first glance. It's just fractions of a cent per gigabyte.
Right, fractions of a cent.
But when you start storing petabytes of telemetry data and application backups and endless user media, those fractions of a cent compound into massive monthly line items. The friction in S3 isn't just about how much data you have, it's about how frequently you retrieve it.
So I was mapping out an architecture using S3 intelligent tiering, and honestly, it looks like the ultimate silver bullet.
A lot of people think that.
Because it automatically monitors your data access patterns, right?
Right.
And it uses machine learning to move your objects between the frequent access tier, the infrequent access tier, and the archive tiers. So my question is, why shouldn't I just enable intelligent tiering across every single bucket in my organization and literally never write a manual S3 lifecycle policy again? Just let the AI do the work.
Well, because the automation behind intelligent tiering isn't free. AWS charges a monitoring and automation fee per 1,000 objects every single month.
Okay, but is it really that much?
Think about it. The system has to actively analyze the metadata of every single object in your bucket to determine when it was last accessed.
Okay, sure. But if I'm storing massive, say, 50 gigabyte 4K video files, a tiny monitoring fee per 1,000 objects is basically a rounding error compared to the hundreds of dollars I save when the system automatically shifts those massive files to a cheaper storage tier.
That is entirely true for large files. But
Yeah.
apply that exact same logic to a bucket holding billions of tiny, like 10 kilobyte text-based log files or user thumbnail image.
Oh, I see.
Right. The monthly fee AWS charges just to monitor those billions of tiny files can easily eclipse the fractions of a cent you save by moving them. You end up paying significantly more for the intelligent monitoring than you actually save on the tiering.
Wow. So enabling intelligent tiering on the wrong bucket architecture could actively increase my monthly bill.
It absolutely can, and it happens all the time.
That completely changes my perspective on manual S3 lifecycle policies. Because, okay, if I have compliance logs that I know for a definitive fact will not be accessed after 30 days, I don't need AWS to monitor them.
Exactly.
I can just write a rigid deterministic rule. After 30 days, transition these objects to S3 Glacier Deep Archive.
Yes. Lifecycle policies are rule-based and deterministic, which means there is no per-object monitoring fee. You bypass the automation tax entirely.
Okay, but what's the catch with Glacier Deep Archive?
The architectural trade-off you have to consider when pushing data to Glacier Deep Archive is the retrieval friction. You secure the absolute lowest storage cost AWS offers, but restoring that data can take up to 12 hours.
Right, so I definitely wouldn't push anything to Glacier Deep Archive that I might need to query during, like, an active incident response.
Yeah,
It is strictly a compliance vault.
exactly. And on the exam, the phrasing is critical here. If a scenario explicitly states data access patterns are unknown or unpredictable, that points directly to intelligent tiering.
But if the scenario gives you a strict timeline, like data is rarely accessed after 90 days, then that points to a manual lifecycle policy.
Spot on. But there is an additional layer of complexity with those manual transitions that you need to watch out for.
Oh, like what?
You can't just blindly transition everything to S3 standard infrequent access to save money. Standard IA has a minimum capacity charge of 128 kilobytes per object.
Wait, a minimum capacity charge?
Yeah, and a minimum storage duration of 30 days.
Okay, hold on. So if I write a lifecycle policy that moves a tiny 5 kilobyte log file to standard IA, AWS charges me as if it's a 128 kilobyte file.
Yes. You are paying for phantom storage.
Wow, I'm artificially inflating my storage volume.
You are, and if you delete that file after, say, 10 days, you still pay for the full 30-day minimum. Frugal architecture requires deeply understanding the fine print of these pricing models, not just skimming the marketing material.
Yeah, clearly. Okay, so we've locked in the optimal pricing rate for compute, and we've plugged the leaky storage bucket. But optimizing the rate is kind of useless if we haven't optimized the underlying resource itself.
Right.
Like, bringing back the real estate analogy, I might have negotiated a killer 70% off lease rate for this sprawling 5-bedroom house. But if I'm living alone, I'm paying to heat and cool 4 empty bedrooms. So even with the huge discount, I am vastly overpaying because I didn't right-size my environment.
And engineering teams do this constantly. I mean, they'll provision an EC2 instance with 16 vCPUs and 64 gigabytes of RAM just to give themselves a comfortable safety buffer.
Right, because nobody wants the server to crash.
Exactly. But over time, the application stabilizes and it only ever peaks at like 4 gigabytes of RAM. So you are paying for 60 gigabytes of unrecoverable phantom capacity every single hour.
Which is wild. Now, the exam sources highlight AWS Compute Optimizer as the solution to this empty bedroom problem. But I really want to understand the mechanics here. Does Compute Optimizer just, look at my average CPU utilization over the last week and guess what instance size I need?
Oh, no. Relying on average utilization is incredibly dangerous.
Why is that?
Well, imagine a server idles at 5% CPU for 23 hours a day, but it spikes to 95% CPU during a critical 1-hour batch processing window. The daily average looks artificially low. If you downgrade the instance based on that average, your server will completely crash during the batch window.
Oh, right, because it won't have the capacity for the spike.
Exactly. So Compute Optimizer uses machine learning to analyze your historical CloudWatch metrics, specifically your CPU utilization, your memory usage, and network I/O over a 14-day look-back period.
Okay, so it has to look at the maximum spikes during that window, not just the average.
Right. It analyzes your P99 peak utilization. It ensures that if you follow its recommendation to downgrade from, say, an M5.4x large down to an M5.large, your application will still seamlessly handle those maximum traffic surges without bottlenecking.
That's incredible. So it calculates the exact monthly financial savings while explicitly protecting your performance baseline.
Yes.
That shifts right-sizing from this terrifying guessing game into a quantifiable, data-driven action. But the well-architected framework's cost optimization pillar stresses that this cannot be just a one-time audit. Right?
No, absolutely not. Software applications are living ecosystems. You deploy new microservices, you acquire a surge of new users, your database queries become more complex over time, the resource demands shift constantly.
You can't just set it and forget it.
No. The well-architected framework demands treating frugality as a continuous operational cycle. You provision infrastructure, you enforce strict resource tagging, you measure the usage, you analyze the waste with Compute Optimizer, and then you adjust.
And resource tagging, that's really the accountability layer, isn't it? Because you can't optimize what you can't attribute. Like, if you tag every EC2 instance in S3 bucket by engineering team or project, you can finally see exactly which team is running those massive underutilized servers.
Exactly. Cost allocation tags transform a monolithic AWS bill into a granular departmental invoice. You embed cost awareness directly into the daily engineering workflow.
Which changes the culture.
It really does. You empower engineers to see the financial impact of their code deployments in real time, rather than waiting for finance to flag an overage 3 months later.
Okay, this is great. Let's actually put this entire frugal architect philosophy to the test. I want to step into the shoes of an architect taking the SAA C03 exam tomorrow morning.
Okay, let's do it.
Give me 3 hypothetical scenarios based on these friction points we've discussed, and let's see if I can navigate the traps.
All right, scenario 1. Your team manages a batch processing application that analyzes financial models overnight. The job takes approximately 4 hours to complete. The application architecture is designed to automatically pause its work, save its state to S3, and resume from the exact same point if the underlying compute server is abruptly terminated. The primary business requirement is to execute this nightly job at the absolute lowest possible cost. What is your compute strategy?
Okay, so my anchor point here is absolute lowest possible cost.
Mm-hmm.
Right away, I'm bypassing on-demand entirely. And the scenario specifically mentions the architecture can automatically pause, save state to S3, and resume.
Right.
That tells me the workload is highly fault-tolerant. It just does not care if the server disappears out from under it. So I am putting this entirely on spot instances. I secure the 90% discount, and if AWS pulls my capacity with a 2-minute warning, the application just pauses and waits for the next cheap instance to become available.
Perfect. You successfully identified the fault tolerance trigger. The ability to pause and resume makes it the perfect candidate for the spot market.
Awesome. Hit me with the next one.
Scenario 2. You are migrating a monolithic e-commerce database to AWS, hosted directly on an EC2 instance. This database is the transactional backbone of the company. It must remain highly available 24 hours a day, 7 days a week.
Okay. Highly available database. Got it.
The CTO projects this specific database architecture will remain completely unchanged for the next 3 years. You need to minimize costs over this timeline.
Okay, so the phrase minimize costs naturally makes me want to lean back into spot instances. But wait, this is a transactional database.
Yes.
If a database server gets terminated with a 2-minute warning, I risk corrupting the transactional state and basically taking down the entire e-commerce platform. So spot is entirely eliminated due to the interruption risk. I need total uncompromising stability because the database has to run 24/7. So to guarantee the server never gets interrupted, I will provision on-demand compute capacity.
You correctly eliminated spot instances by recognizing the technical constraint of the database, but you fell directly into the financial timeline trap. Review the business constraints again. The architecture will remain completely unchanged for the next 3 years.
Oh, right. If I pay on-demand rates for 3 straight years, I am paying the premium hotel rate for over 1,000 nights.
Exactly.
That is a massive mismanagement of capital. I have absolute certainty that I will need this exact capacity for a 36-month window. So the answer isn't on demand. I need to leverage that certainty and commit to a 3-year reserved instance or a 3-year compute savings plan to slash the hourly rate.
Spot on. The exam intentionally sets up on-demand as a decoy by overemphasizing the need for 247 stability. You must recognize when a predictable multi-year horizon allows you to leverage commitment discounts without sacrificing that stability.
That is such a tricky way to word the question, but it makes total sense. Yeah. Okay, last one.
Scenario 3. Your application allows users to upload high-resolution profile pictures. You receive tens of thousands of these image files daily.
Tens of thousands, okay.
System analytics definitively prove these images are heavily accessed for the first 60 days. After 60 days, access drops to almost 0, but compliance regulations mandate you retain all images indefinitely. How do you architect the storage to optimize costs?
Okay, so tens of thousands of files every day means I am dealing with millions of files over the life cycle of the application. My initial instinct is to rely on S3 intelligent tiering. I can let the AWS machine learning monitor the access patterns and just automatically migrate the profile pictures into colder storage when users stop accessing them after day 60. It completely removes the operational burden from my team.
Recall the underlying mechanics of S3 intelligent tiering, though. What happens to your monthly bill when you apply that automation to millions of relatively small image files?
The monitoring automation fee.
Yep.
I completely ignored the per object tax. AWS is going to charge me a monitoring fee for every single one of those tiny profile pictures every single month. The cumulative monitoring cost for millions of small files would likely exceed the actual storage savings.
It definitely would.
Furthermore, the scenario gave me a definitive, predictable access pattern. Heavily accessed for 60 days, then basically zero.
You have a deterministic timeline.
Right. I don't need machine learning to guess what my users are doing. I will write a manual S3 lifecycle policy that explicitly states, after 60 days, transition all objects to S3 Glacier Deep Archive. I bypass the automated fees entirely and lock in the absolute lowest storage tier for the compliance data.
Excellent. You recognize the financial trap of deploying intelligent tiering against high volumes of small files. Leveraging a manual lifecycle policy for predictable data is absolutely the most frugal architectural decision there.
The wording in these scenarios is just incredibly deliberate. You really have to understand the mechanical friction between these services, not just what they do on paper.
That's the
So bringing this all together, mastering the frugal architect principles, basically comes down to establishing a few rigorous engineering habits. You align your compute purchasing model with your workload predictability, so leveraging Spot for flexibility and savings plans for certainty. You optimize storage by balancing the operational convenience of intelligent tiering against the hidden automation fees of millions of small objects.
And of course, you relentlessly right-size your instances using the P99 machine learning analysis provided by Compute Optimizer. That ensures you strip out phantom capacity without risking your application performance. Ultimately, cost optimization fundamentally shifts cloud infrastructure from a static capital expense into a dynamic, measurable operational metric.
Absolutely. And whether you are walking into the testing center for the SAACO3 exam tomorrow morning, or you're a principal engineer trying to slash your startup's AWS burn rate before the next board meeting, these are non-negotiable business skills. You are making financial commitments with every single line of infrastructure code you deploy.
You really are.
So I want to leave you with a final thought to chew on as you review your own architecture. AWS generates its revenue by selling you server space, storage capacity, and network bandwidth. The larger your infrastructure footprint, the higher their revenue. So why does AWS invest millions of dollars developing incredibly sophisticated free tools like Compute Optimizer and the well-architected framework, which are specifically designed to help you pay them less money? What does that reveal about the underlying long-term strategy of cloud economics? Something to think about. Until next time, keep optimizing the architecture.